The vehicle master cylinder brake is a critical part of the braking system, converting the pressure from the brake pedal into hydraulic force. Positioned near the driver's side firewall, it contains brake fluid reservoir and a piston. When the driver presses the brake pedals, the piston generates hydraulic pressure that travels through brake lines to each wheel's brake caliper or cylinders. This pressure prompts the brake component to apply friction to the rotor or drums, slowing down or halting the vehicle. The master cylinders design typically includes separate chambers, ensuring some braking capability even if a leak occur in one section, thereby enhancing safety. Regular maintenance, such as monitoring brake liquid levels and promptly addressing any issues, is crucial to keep the master cylinder and the entire braking system functioning effectively and safely.
Boss Gene on the beat.
the working process master brake cylinder. Firstly, we must pressing the brake pedal applies force to push rods or booster connected to the master cylinder, and then we must apply the force to move a piston within the master cylinder sealed by the rubber cups. The piston movement generates pressure in the brake fluid stored in the master cylinder reservoir. This pressure is transmitted through brake lines to individual brake calipers or wheel cylinder. The hydraulic pressure forces brake pads or shoes against rotors or drums, creating a friction and slowing down the vehicle. Releasing the brake pedal reduces pressure, allowing pads or shoes to retract from rotors or drum. The master cylinder reservoir ensures the replenishment of brake fluid, maintaining optimal level for consistent performance. Okay, for the inspection for master brake cylinder, firstly we must do the visual examination by checks the leaks or seepage around the cylinder, particularly at the connection and seals. Look for the exterior corrosion or damage. Next, verify the brake fluid level and it clean lineless in the reservoir. Contaminated or low fluid levels could indicate issues. And then test brake pedal movement for smoothness and responsiveness. Nothing any unusual resistance. Ensure seals around the master cylinder are intact and check brake lines for leak or damage. Evaluate the vehicle braking response during a safe test drive, not noting any irregularities or noises. And finally is, if any concern arise, seek a professional mechanic assessment to ensure thorough inspection and potential maintenance.
So I will continue with the master cylinder parts name. So for the number one is fully reservoir. Number two is reservoir cap, baffle, strainer, float reservoir, socket brake fluid sensor. Number seven is lock pin. Number eight is reservoir body. Number nine is reservoir grommet. Number 10 is master cylinder pin. 11 is valve seal. 12 is primary piston assembly. Meanwhile, the 13 is the secondary piston assembly, and the last one is master cylinder body. So the next one is about the result that we gain for the condition of the master cylinder during our lab session. So for the first one is about the inner surface of the master cylinder itself. So in the inner surface got no leak on the oil sphere. So the second one is about the primary and secondary piston, which is got a little rusty due to got no brake oil in there, but it is still in a good condition. So the third one is about the diaphragm, which is in a good condition, and it's the same condition also with the brake booster, which is also in a good condition. And the last one is about the O-ring, which is not in a good condition due to the O-ring is a little bit bended. And for the result, the inspection of the master cylinder that we gain through the push rod and length. So before we push up the brake pedal, the length for the push rod is about 27 mm only. But after we push the brake pedal, the push rod and lengthen until it reach 53.3 mm. I will continue the presentation by explaining the discussion one that talk about the effect of push rod and length on the brake. So it will affect the pedal travel during the braking process, which is a short push rod led to a less pedal travel, which makes the brake feels more responsive, but a longer push rod led to more pedal travel, but reducing the effort needed by the driver. So the second effect is touching about the pedal feel itself. A short push rod led to a firm and hard feel for the driver during the braking, but a long push rod tend to soften the brake feels to driver. And the last one is about the master cylinder stroke itself. A longer push rod reducing the master cylinder stroke, and that may lead to the insufficient pressure when emergency braking. Discussion 2. Type of brake oil used in Malaysia. There are two common base brake oil that always be used in Malaysia. For the first one is glycol based brake oil that always used for .3, .4 and also .501. This type is commonly used and has unique qualities. And the other one is a silicone based that is a bit different from glycol based due to its type that does not absorb moisture from the air. Plus, it's having a stability and consistency viscosity under a broad temperature range and conditions. To answer the question about can a different type of brake oil be used, the answer is wrong or cannot be used or mixed due to its different unique aspects, such as in terms of compatibility, a particular kind of brake fluid is intended to be used with certain brake systems. Using a different kind could result in corrosion, braking performance issue, and also damage to the seals. Second, the different or variety of boiling point. Maintaining efficient braking performance, particularly when braking heavily or for an extended period of time, requires knowing the brake fluid's boiling point. In severe circumstances, using a fluid with a lower boiling point than advised might cause a brake fading or even brake failure during needed. Discussion 3. Hydraulic tubes that are connected to the master cylinder. The inflexible metal tubes known as brake lines serve as a connection between the master cylinder and the wheel cylinders or brake caliper at each wheel. Steel or similar material resistant to corrosion is frequently used to make them. The high pressure brake fluid needed to activate the brake is carried by the brake lines. Flexible tubes known as brake hoses are used to join the brake lines to the wheel cylinders or brake calipers. Usually reinforced rubber or other flexible materials are used to make them. Brake hoses maintain a hydraulic connection between the fixed brake lines and the moving parts at the wheel while allowing for movement and flexibility in the suspension. So, the discussion 3 asks about where all the tubes connected. The entire hydraulic system is designed to transmit hydraulic pressure from the master cylinder through the brake lines and hose to the brake component at each wheel. So it will start from the master cylinder to the brake booster, which is servo, and from the master cylinder to distribution block or control module, distribution block to the front and rear brake lines, and from the brake hose at each wheel. Discussion 4. Function of diaphragm. The word of brake diaphragm is frequently used in relation to the vacuum brake booster, which lessens the force a driver has applied to the brake pedal in power exercise brake system. The brake diaphragm is an essential part of the vacuum brake booster, and the braking system needs it to function properly. The vacuum booster assembly, which is normally situated between the master cylinder and the brake pedal, include the brake diaphragm. Its main purpose is to use vacuum pressure to help the driver apply the brakes. The brake diaphragm also amplifies the force applied by the driver when they depress the brake pedal by using vacuum pressure produced by the engine. This facilitates the master cylinder's effective and efficient actuation. Engine vacuum is used to power the vacuum brake booster. The braking diaphragm is an airtight, flexible membrane that divides the booster's vacuum side from its atmospheric side. The diaphragm moves as the brake pedal is depressed, resulting in a pressure difference that helps activate the brakes. The brake diaphragm returns to its rest position when the brakes are engaged and the driver lets go of the brake pedal. The system is now ready for the subsequent brake application.
Finally, in summary, conducting a comprehensive examination of the master cylinder is crucial for maintaining a safe and effective brake system. If any issues are identified during the inspection, it is recommended to address them promptly to prevent potential safety hazards and ensure the reliable operation of the vehicle's brakes. If there are specific concerns or observe a certain symptom, further diagnostic and professional assistance may be necessary. Thank you.